Optical simulation tools, modeling and designing optical networks. Optical simulation tools, modeling and designing optical networks. In recent years, optical networking has become an essential part of the telecommunications industry. Optical networks offer high bandwidth and are capable of transmitting data over long distances without significant signal degradation. Optical simulation tools are an essential asset for designers and installers when evaluating and optimizing various aspects of optical networks. Optical simulation tools are computer programs designed for modeling and analyzing the behavior of optical systems. These tools enable designers to simulate the performance of optical networks before they are built, allowing for more efficient and accurate evaluations. The simulation process can include the analysis of optical components, network topology, and performance optimization. One key area in which optical simulation tools are useful is in evaluating the performance of optical components. Optical components are devices that manipulate light, including sources such as lasers and detectors such as photodiodes. Simulations can help designers evaluate the performance of these components under various operating conditions, such as temperature changes, signal amplification, and modulation schemes. Optical simulation tools can also help designers and installers evaluate network topology designs. Network topology refers to the arrangement of optical components within a network, including the placement of sources, amplifiers, and receivers. Different topologies can affect network performance and efficiency. For example, some topologies may have more loss than others, while others may be more difficult to install and maintain. By running simulations on different network topologies, designers can test the performance of the network and optimize its design. They can evaluate the performance of the network under different operating conditions, such as traffic load and temperature fluctuations. Simulations can also help designers determine how many amplifiers and regenerators are required and the optimal placement of components. Another important use of optical simulation tools is in the design of wavelength division multiplexing (WDM) systems. WDM systems are used in optical networks to transmit multiple signals simultaneously over a single optical fiber. This technology allows for the transmission of large amounts of data over long distances. Optical simulation tools help designers optimize the performance of WDM systems by examining variables such as polarization mode dispersion, PMD, chromatic dispersion, and nonlinear effects. These effects can result in signal distortion and degradation, and simulation allows designers to optimize the performance of the system by minimizing these effects. Optical simulation tools are also useful in the study of time division multiplexing (TDM) systems. TDM technology allows for the transmission of multiple channels of data over a single optical fiber. Using time intervals. TDM systems require precise synchronization to operate correctly, and simulation can help designers evaluate the performance of TDM systems under various synchronization conditions. In addition to evaluating network topology and performance, optical simulation tools can also help designers troubleshoot problems with existing optical networks. By simulating the behavior of an existing optical network, designers can identify problems and evaluate potential solutions. This approach can save time and money, as problems can be identified and addressed before they become critical. One of the most powerful optical simulation tools is the Optical Time Domain Reflectometer, OTDR. The OTDR can determine the location of the fault by measuring the time delay between the pulse and T. He reflection, as well as the intensity of the reflection. OTDRs can also help designers evaluate the performance of optical networks by detecting loss and reflection events along the fiber. The OTDR measures the amount of light that is reflected by the fiber at each discontinuity, allowing designers to determine the amount of loss in the network. Another important optical simulation tool is the Optical Spectrum Analyzer, OSA. An OSA measures the spectral content of an optical signal, allowing designers to evaluate the performance of WDM systems. EMS. By analyzing the spectral content of each signal in a WDM system, designers can determine if the signals are properly spaced, and if the system is operating within the desired wavelength range. In summary, optical simulation tools offer designers and installers a powerful toolset for evaluating and optimizing optical networks. These tools enable designers to simulate the behavior of optical systems before they are built, allowing for more accurate and efficient evaluations. Optical simulation tools can help designers evaluate the performance of optical components, network topologies, and WDM systems. They can also help troubleshoot existing networks and identify potential problems. The Optical Time Domain Reflectometer and Optical Spectrum Analyzer are two key simulation tools used in the industry. With optical simulation tools, designers and installers can optimize network performance, increase efficiency, and save time and money. Optical simulation tools are constantly evolving, as the demand for higher performance and greater efficiency in optical networks increases. For example, some modern simulation tools use machine learning algorithms to optimize network performance. Machine learning algorithms can analyze vast amounts of data to determine optimal network configurations and modulation schemes. These algorithms can also predict network performance under different operating conditions, allowing designers to choose the best approach for their network. Another emerging area in optical simulation is the use of virtual reality, VR, and augmented reality, AR, technologies. These technologies allow designers to visualize and interact with simulated objects.